Hello, welcome to lesson 18. In this lesson, we are going to look at some more examples on the relationship between the critical angle C and the refractive index N. We derived this in the previous lesson and we want to use it in this lesson. Let's see this example. The critical angle for water-air interface is 48 degrees and 42 minutes, and that of glass-air interface is 38 degrees and 47 minutes. Calculate the critical angle for the glass-water interface. So we are looking at glass-water interface. Let's have this illustration. We want C, so we are going to apply Snail's law here. We're going to apply Snail's law in the glass-water interface. So we shall have N glass sine C is equal to NW sine 90 degrees, since the angle of refraction is 90 degrees. And then we know that the critical angle for the air-water interface is 48 degrees 42 minutes. So we are going to use this to get the refractive index of the water. So we shall use the relation N sine C is equal to 1. So we shall have NW sine CW is equal to 1, and therefore we shall get NW as 1.33. Then after doing that, we shall also do the same for the glass air interface. Then we shall apply Snail's law and then get NG sine CG is equal to 1, and then make NG the subject and get NG as 1.67. After getting that, we are going to replace or substitute for NW and NG in equation 1. When we substitute, we shall get 1.67 sine C is equal to 1.33 sine 90 degrees. Then we shall get our C as 52.8 degrees. Let's also look at this other question. The refractive index of red light is 1.634 of crown glass, and the difference between the critical angles of red and blue light at the glass air interface is 0 degrees 56 minutes. What is the refractive index of crown glass for blue light? Maybe what I forgot to talk about this is that you can write this, or you can punch in this in the calculator. We have a button which you can press to get the degrees and then also get the minutes or even seconds if you have, if there was seconds. So you can do that, or if not, you can just get 56 divided by 60 and then add to 0, and then it will be in degrees. So you choose what you prefer. So let's get this. So we are seeing that the critical angle for the red light is greater than the critical angle for the blue light, which implies that the difference here is going to be CR minus CB is going to give us 0 degrees 56 minutes. And also we are going to apply Snail's law, but for the red light, since we have the refractive index of the red light, so we shall have Snail's law for the red light. Then substitute for substitute for NR, then we get CR. So CR is going to be 37.73 degrees. Then after that, we are going to replace or substitute for CR in equation 1 and then get CB, which is going to be 36.8 degrees. Then we apply Snail's law to the blue light, this relation N sine C is equal to 1, which will give us N for the blue light is going to be NB sine CB is equal to 1. Then after getting that, we are going to get NB as 1.67. Let's look at the next question. So we have a glass block of refractive index Ng is immersed in a liquid of refractive index Nl. A ray of light is partially reflected and refracted at the interface such that the angle between the reflected and the refracted ray is 90 degrees. Show that Ng is equal to Nl tan alpha, where alpha is the angle of incidence from the liquid to glass. So they want us to show this. So this is the setup or the illustration. The angle of incidence is alpha, so the angle of reflection is also going to be alpha by the second law of reflection. And then this is r, the angle of refraction. Then the angle between the reflected ray and the refracted ray is 90 degrees, which implies that we can get this angle r. So first of all, applying Snail's law in the liquid glass interface, we shall have N G sine r is equal to NL sine alpha. That is, if we are moving from glass to the liquid, or it can be from the liquid to glass, which will be NL sine alpha is equal to Ng sine r. But we have no r here, so we need to replace for r here. So we are going to add alpha plus 90 plus r is equal to 180. Angles on a straight line. So r is going to be 90 minus alpha, and therefore we shall have Ng sine of 90 degrees minus alpha is equal to NL sine of alpha. But from trigonometry, we know that sine of 90 degrees minus alpha is the same as cos of alpha from trig. So if we replace that with cos alpha, we are going to have Ng cos alpha is equal to NL sine alpha. And then divide it through by cos alpha, we shall have Ng is equal to NL divided by, NL times sine alpha divided by cos alpha. Sine alpha divided by cos alpha is tan alpha, so we shall have Ng is going to be NL tan of alpha. And hence we would have proved that Ng is equal to NL tan of alpha. Let's look at the next question. In this question, they are saying that when the procedures in one above are repeated with the liquid removed, the angle of incidence increases by 8 degrees. Given that NL is 1.33, find Ng and the angle of incidence at the air glass interface. So we are changing the angle of incidence and increasing it by 8, and then we are removing the liquid. So we shall have this. This is the illustration. So the angle of incidence is now alpha plus 8. Angle of refraction remains r, and then this is still 90. So we are removing the liquid, and then we shall remain with air. So from the relation that we derived, we are going to replace NL with air, or Na, where Na is equal to 1, and then when we substitute there, also we shall replace alpha with alpha plus 1, because the angle of incidence changed or increased by 8. So it is alpha plus 8. Then where Na is equal to 1, we shall put here 1, then we shall have N is equal to tan of alpha plus 8. Then from trig again, tan of alpha plus 8 is equal to tan of alpha plus tan of 8 degrees divided by 1 minus tan alpha tan 8 degrees. So we shall have this. Cross multiply so that we remove this from the denominator. Then we shall have Ng into brackets 1 minus tan alpha tan 8 degrees, and then is equal to tan alpha plus tan 8 degrees, which will give us this. That is our second equation. Then from first equation, we shall make tan alpha the subject, and then we shall get tan alpha as Ng over NL, then replace it, then we shall replace it in equation 2, then we shall substitute in equation 2 and have that where NL is actually 1.33. When we put here 1.33 and here 1.33, and then collect like terms and then simplify that, we are going to have the quadratic equation given by, we are going to have this kind of quadratic equation being formed when n squared g has has here 1. So if we make this one, of course, when it is here, it will not be having 1, but if we divide through and make it 1, then we shall have this kind of quadratic equation. So if you get that quadratic equation, we shall solve that quadratic equation using a calculator or using a formula. But since we are just applying, we shall use a calculator, and then we shall get Ng as 1.38 or 0.95. But we know that the refractive index of glass is greater than 1, so this one will not be possible. So we shall use Ng to be 1.38. So after that, we shall substitute for Ng in equation 1, or in this, and we shall have tan of alpha is equal to Ng over NL, which is equal to 1. This was supposed to be 1.39, not 1.38. It was an error here. So this 1.39 over 1.33, and then we shall get alpha as 46.3 degrees. But remember, we want the angle of incidence at the air glass interface, which is this air glass interface. So we shall add alpha plus 8, which will give us the required value as 54.3 degrees. Let's look at this question lastly. The figure below shows a liquid layer confined between two transparent plates X and Y of refractive index 1.54 and 1.44 respectively. Now a ray of monochromatic light making an angle of 40 degrees with the normal to the interface between the media X and the liquid is refracted through an angle of 50 degrees by the liquid. Find the refractive index of the liquid, the angle of refraction R in the medium Y, the minimum angle of incidence in the medium X for which the ray of light, which the light will not emerge from Y. Let's begin by looking at the refractive index of the liquid. So we shall use this media X and the liquid. So let's look at the interface between X and the liquid. So we shall apply Snail's law there, and we shall have Nx sine 40 is equal to Nl sine 50, and then we shall make Nl the subject and then get Nl as 1.29. So that is straightforward. Then we shall continue with this next question. The angle of refraction R in the medium Y. So we are going to apply Snail's law in the interface between the liquid and medium Y. We have already known that this is 50, so it means that this angle is also 50. The angle of incidence here is 50, since they are alternating. So if this is 50, apply Snail's law, we shall have NL sine 50 is equal to NY sine R. So apply Snail's law and then make sine R the subject, and then we shall get R as 43.3 degrees. Then lastly, they want us to get the angle of incidence, the minimum angle of incidence for which the ray will not emerge in media Y. So it means it will be grazing. So it will be grazing, so the angle of refraction at Y is going to be 90 degrees. So this is going to be 90 degrees. And therefore, this one is going to be I1, and this is also going to be I1, and this is IX. So we are looking for IX. So let's apply Snail's law in the liquid medium Y interface, which will be NL sine of IL is equal to NY sine of 90. This is I1, and we're moving from the liquid to Y. And then also we know that NL is 1.29, and then NY is 1.44. So if we substitute for that and make sine L sine of IL the subject, we shall have 1.44 divided by 1.29. That is equation 1. Then also we shall apply Snell's law in the interface between Y and between X and L and the liquid. So applying Snell's law there, we shall have Nx sine Ix is equal to NL sine IL. That is if you apply it here. So you always apply Snell's law at the boundary where refraction takes place. So we shall substitute for Nx with 1.54, and then NL is 1.29. Then we shall get this. But from equation 1, we know that sine of IL is 1.44 divided by 1.29. So if we replace that, we shall get this. Then 1.29 will cancel with 1.29, this and that. Then we shall have sine of Ix is equal to 1.44 divided by 1.54. And then we shall get our Ix as 40.5 degrees, which implies that the minimum angle of incidence for which the ray will not emerge from Y is 40.5 degrees. Thank you for your attention. In the next lesson, we shall introduce refraction through prisms.